Hi, this is Mark Samueda with Pluralsight. This module is titled Program Flow. We've seen how our JavaScript programs so far flow from top to bottom, but sometimes you don't always want that. Sometimes we want to include extra code, or exclude certain code, or even loop over the same code continuously. And this all refers to the flow of our code. Let's take a look at what we'll cover in this module. We'll start off by looking at if-else statements. This allows us to set up certain conditions which will allow certain code to execute. If a condition is met, we'll execute some code. Else, we'll execute other code. Next, we'll look at truthy and falsy expressions. When we're working with conditionals, the conditionals generally evaluate to true or false. But there are certain values of certain variables that take on a true nature or a false nature. And that's where we get the terms truthy and falsy. We'll look into this and we'll make sure we understand how to work with conditionals properly. We've seen the equal sign as an assignment operator. We assign a value to a variable using the equal sign. But there are two other symbols that are important to know: the triple equal sign and the double equal sign. So we'll take a look at these. And there's a special ternary operator in JavaScript. This deals with a condition and two different statements that could execute based upon the condition. We'll see the syntax for this. And next we'll look at block scope. When we're working with blocks of code, we're allowed to declare variables within that block. And when the block completes, the variables disappear. We'll see how this works. And finally, we'll look at looping through code. We can create for loops, while loops, and do while loops. And we'll look at examples of each and the syntax for each. So let's get started working with conditional code with the if statement. Very often in JavaScript, we need to conditionally execute some code. If a condition is true, we want to execute a code block. But if the condition is false, we don't want to execute it. Let's see how this works in JavaScript. We use the if keyword in an if statement. A statement is simply giving a command to JavaScript. And the way this works is we specify the keyword if, and then in parentheses we put the condition. In this case, we're checking if 5 is equal to 5. That's what the three equal signs mean. We saw how a single equal sign let us assign a value to a variable, but we're not doing that here. We're comparing, so we use three equal signs. So if 5 is equal to 5, we execute this code block. A code block is code that exists between opening and closing parentheses. So in this case, because 5 is equal to 5, we'll log out the word yes. The condition is true. In this next if statement, the condition is false. If 5 is greater than 10, execute this code. The word no is never going to show in the console. The code will not execute. But you can see how we can use a greater than sign. We could also use a lesser than sign. And in this third example, if 5 is greater than or equal to 5, we write out yes. And that's true. 5 is greater than or equal to 5. Likewise, we could check for less than and equal to 5. In these examples, we're working with literal numbers. But most of the time, you're going to be working with variables, or a variable and a number. Let's see some more examples. Here we're creating a variable state, and we're setting it to FL for Florida. And we're creating another variable called tax%, which we're setting to 0. Then we have our conditional if statement. If state is equal to Florida, FL, we want to set tax% to 7. And the condition is true. Tax% will be set to 7. And when we log out tax%, we get 7. So we're comparing a variable to a string. And again, notice we're using the triple equal sign. It's a very common bug to use a single equal sign or a double equal sign. So make sure that in our conditionals, we're using three equal signs. And in this example, I made a small change. We're starting off by setting tax% to 7, but now we're checking for an inequality, not equal to. And we do that with the exclamation point, which means not, and two following equal signs. So if the state is not equal to Florida, we set the tax% to 0. But the state is equal to Florida, so that code never executes. When we log out tax%, we get 7. But the key takeaway is that the not double equal sign checks for an inequality. Let's go to Visual Studio Code and write our first if statements. So I have a simple if statement, and the code block, that's the code between the parentheses, will show the message true. So inside of the if statement, I'll simply put the word true. So if true, show the message true. I'll save it. And true shows up. Likewise, we can specify false here. I'll save it. And the original HTML markup shows get a grip. This code is not executing. We can put some literal numbers in here as well. If 1 equals 1, we'll show true. I'll save it, and we get true. If 1 is equal to 2, I'll save it, and true does not show up. I'll create a variable, let price equal 20, and then we can compare price to a value. If price is greater than 15, we'll show the message discounted. I'll save it, and we get discounted. But if we say if price is less than 15, I'll save it, and discounted does not show. So the symbols we can work with are greater than, less than, or we can put a greater than or equal to symbol, or a less than or equal to symbol. But probably the most common ones are identically equal, which are the 3 equal signs, or not identically equal, which is exclamation point equal equal. In this case, if price is not equal to 15, we'll show discounted. I'll save it, and we get discounted showing up. So these are the very fundamentals of if statements. You're going to be using if and other conditionals all the time. So it's very important to understand what is true and what is false. This can get tricky in JavaScript. So the next clip, we'll take a look at this. So we've seen our first conditionals with the if statement, and between the parentheses after if, there needs to be an expression that evaluates to either true or false. And in JavaScript, we describe the quality of this as either being truthy or falsy. So let's look at a few examples and a few of the quirks in JavaScript. And we'll start off with falsy, because truthy is the opposite of falsy. Obviously, the Boolean value false is false, and the number 0 is false, but only the number 0. When it comes to strings, a string is false if it's empty. So if we have 2 quotes right next to each other, whether it's double quotes or single backticks, so as long as there are no characters between the quotes, it's false. And we saw the value null. That evaluates to false, and undefined also evaluates to false. And we also saw the special symbol not a number, NaN. That evaluates to false as well. So if all of these are false, what's true? As a developer, the easiest way to remember what's true is simply remember what's false, and it's everything else. So everything not falsy is truthy. So obviously the Boolean value true is truthy. Any number besides 0 is truthy. So 0.5 is truthy. And this is where things get a little bit tricky. But if you had a 0 showing as a string, here it's in double quotes, that's actually truthy. But the number 0 by itself without quotes is falsy. So when we write our conditions, we need to keep this in mind. Let's go back to Visual Studio Code and look at some of the trickier examples. Here's our code from the last clip, and I'll clean this up for a second. I'll take out the variable, and let's just put a quoted 0 in here, and I'll show the message true. I'll save this, and we get the message true. You would think 0 would be false, but it's not, as long as it's a string. So let me take out the quotes and just have the number 0 there, and I'll save it. And true does not show. So it's very important to keep that in mind. And one other important thing to keep in mind is what we saw earlier. We saw that 1.1 plus 1.3 is actually not equal to 2.4. Remember that JavaScript uses inaccurate floating point numbers. So if I save this, we get true. So this is a case where JavaScript and floating point arithmetic really lets us down. This could throw off our calculations, especially if we're using greater than or less than. The way to fix this is to always round off your numbers. So to round off 1.1 plus 1.3, one thing I can do is I could put it in parentheses. And by putting it in parentheses, I can now treat it as an object. I can put the dot symbol and type 2 fixed. So this will create a fixed number with 2 decimal places because I entered the number 2 here. But the problem with 2 fixed is that it returns a string. We need to convert all of this from a string to a number. And the easiest way to do this is by adding a plus sign before the parentheses. You can think of the plus sign as similar to the negative sign. Negative would make the number negative, but the plus sign just leaves it as it is. But it does have the benefit of converting a string to a number. So when I save this now, it does not show true, which is correct, because I'm checking for not equal to. If we wanted to check for equality, I'll enter the triple equal symbol, and I'll save it. and things are good. So the key takeaway here is that when you're working with floating point numbers, you always need to convert the floating point number to a fixed amount of decimal places if you're going to compare it to a literal, such as 2.4. If you don't do this, your calculations could be off. And also remember that the plus sign is a simple way to convert a string returned by 2 fixed back into a number. And another thing about code blocks is we've only been working with one line of code, but we can put as many lines of code as we'd like between the opening and closing parentheses. I can create a variable, let message equal hello, and I can use that variable here. And we can have as many lines of code here as we'd like, and we can also put if statements within other if statements. That's very common. I'll save this, and we get hello. We've seen the if statement, but there's a special clause that we can add to the end of an if statement where we can specify a code block that'll execute if the condition is not true. We use the else keyword. Let's see some examples. Looking at this if statement, if state is identically equal to FL for Florida, we execute this code block. We can also specify an else clause. Else execute this code block. So if state is not equal to Florida, this code block will execute. When we log out tax percent, we get 7 because state is equal to Florida. Let's see another example. Here's our if statement and our else clause, but we're immediately adding another if statement to the else clause, and that's fine. So if state is identically equal to Florida, we execute this code block. Else, if state is equal to New York, we execute this code block. And this is a very popular construct in JavaScript, to have an if statement and one or more else if statements following that. Let's go to Visual Studio Code and look at this live. So here we have an if statement. If true, we'll show the message true. And let's add an else clause to it. Else, and we'll specify a block of code with the opening and closing parentheses. We'll show the message false. I'll save this, and we get true. Likewise, if our expression in the if statement evaluated to false, I'll save it, and false shows up in the browser. So in this case, our else clause executed, and we show message false. Normally this would be used with some kind of variable. Let's let price equal 20. If price is greater than 10, we'll show the message true. And just to see this working, I'll save it, and we do get true. But let's add another if statement after our else keyword. Else, if price is less than 5, let's just show a message less than 5. And we'll set price equal to 4 to test this. I'll save it, and we get less than 5. So this condition here evaluates to false. So else is checked, and if price is less than 5, which it is, we execute this code block here, and we get the message less than 5. One other thing I'd like to show you is that these braces aren't required. Sometimes you'll see code without them. I'll take these out, and this is a legal syntax. After the condition, you can either have a block of code, as we've been using, or you can have a single statement, as we see here. And I'll save this just to show it works. We get less than 5 still showing up. But it is a best practice to always use the curly braces. It avoids confusion, and it makes it very obvious that the code belongs together as a block. If at a later time we wanted to add more code, the curly braces will already be there. So I'll put those back in. Another common thing we usually see is multiple else keywords. This is legal as well. We can put as many elses or else ifs as we'd like. Let's check for less than 4, and we'll set the price equal to 1. And let's just say greater than 5 here. So if price is greater than 10, we'll show true. If price is greater than 5, we'll show greater than 5. And if price is less than 4, we'll show less than 4. I'll save it, and we get less than 4. So just remember, it is a best practice to always use curly braces, even if a code block only has one line of code. When we test for equality, we've been using 3 equal signs, but there's another symbol which uses just 2 equal signs. Let's see the difference between these 2 symbols and why using 3 equal signs is a best practice. We have an if statement that's comparing the number 1 with the string 1, and we're using the triple equal sign. I'll save this, and we get false. So a number 1 is not equal to a string 1 when we use the triple equal signs. However, if we use two equal signs, I'll save this, and we get true. So when we use two equal signs, what happens is that JavaScript will attempt to convert types. It'll convert the number 1 into a string 1. So the comparison is true. And this can be very confusing at times. When you compare numbers or variables, you want to make sure you're comparing the same type. And that's why we use three equal signs. If the types are different, it'll evaluate to false. Again, I'll save this and we get false. Sometimes the triple equal sign is read as strictly equal to or identically equal to. And that's because the types need to be the same. Likewise, there's a not equal to symbol. So the number 1 is not equal to the string 1. I'll save this and we get true. That's correct. But if we just use the exclamation point and one equal sign, again, this is similar to the double equal sign. JavaScript will convert the number 1 into a string 1. I'll save this and we get false, which could be confusing. So it's a best practice to always use, for inequalities, exclamation point with two equal signs. Or for equalities, you would just use the three equal signs, as we see here. In the next clip, we'll take a look at a shortcut for creating if-else statements. There's a special operator in JavaScript called the ternary operator. It's called ternary because it works with three different values, and it's a shortcut for working with if-else statements. Now, it does look a little bit cryptic. There are some symbols that you need to know. First of all, it starts out with a condition, just like with an if statement, but no if keyword. Following the condition, we have a question mark. And if the condition is true, the true statement will execute. That's followed by a colon and a false statement. If the condition is false, the false statement executes. So to see this in action, we're checking for price greater than 10. We have our question mark, and if price is greater than 10, let's assume it's set to 20 and it is, then we'll use the value expensive. Else, which is symbolized by the colon here, we'll use the value cheap. So at the end of this line, the variable message will either hold expensive or cheap, one of those strings. And if price is set to 20, it'll show the message expensive. If price is less than or equal to 10, it'll show the message cheap. Let's look at this in our editor. So we're setting price to 20, and we have our condition. Price is greater than 10. That'll be true, so our true statement should execute. Show message yes. If price were less than or equal to 10, we would show message no. I'll save this. And we get yes as expected. Let's change the condition to less than 10. I'll save it. And now it shows message no. One thing I want to point out is that these parentheses are not required. I'll just remove them before price and after 10. And we still have a condition here. Price is less than 10. And just to show we don't have an error, I'll open up the console. And I'll save the code. And you see we get the value no with no error. So it's fine to leave out the parentheses, but I like to keep them in just because it makes it clear that it is a conditional and where that conditional begins and ends. Here our true statement and our false statement each execute a function, but many times we just see a simple value here. I'll just change this to yes as a string, and I'll change the false statement to no as a string. But we would need to assign this to some variable to make use of it. So I'll say let message equal, and depending upon the condition, it'll evaluate to yes or no. And I'll use message here. I'll save it, and we get no. So you'll see the true statement and the false statement either be values or function calls, but each is only one single statement. And again, this is called the ternary operator because we have three statements: the condition, the true statement, and the false statement. When we started working with if statements, we started working with blocks of code. A block of code exists between the open and closing parentheses. And we can actually declare variables within a block. And if we declare that variable using let or const for constants, that variable will only be available in that block. And this is very important to understand because variables might seem to disappear otherwise. Let's take a look. So we have a simple if statement. If true, we'll show the message true. Let's declare a variable within the code block. We'll let value equal yes. And then we'll show message value. I'll save this, and we get yes as expected. But the question is, can we access this variable that we declared in the block? Can we access it outside the block? I'll console.log value. I'll save it. And you can see that we got an error because it paused. So I'll go to the console and I'll resume the debugger. And we can see the error is uncaught reference error. Value is not defined. So we declared value here in a code block, but we cannot access it outside of that code block. And that's a good thing. That way we can encapsulate some code and not have it leak outside the block. Now this behaves very differently if we use the old keyword var. Let me change let to var, which is not a best practice. And I'll save this and we'll see what happens. So in this case, it console.log value as yes. So our variable value leaked outside of the code block. And that's very confusing, especially if you come from another language such as Java or C#. When you have a code block, any variables declared inside it should stay only within that block. And that's why it's a best practice to always use let. Or if you have a constant, use const. Let me change this to a constant because it's not changing. I'll save it. And we get the error that we expect. I'll go to the console and resume it. And value is not defined, which is correct. We're trying to access value outside of a code block where it was declared. So we should get this error. We've seen several ways to conditionally execute code. That will either execute the code or skip it altogether. But sometimes we need to loop over code. We need to execute the same code over and over and over. One way to do this is with a for statement. Let's take a look at this. The keyword for lets us create a loop. And this might look pretty cryptic, but let's break it apart. We use the for keyword, and then we have a few different things in opening and closing parentheses here. The first thing we have is a statement. Here we're declaring a new variable I, and we're setting it to 0. And this is the first thing that executes in a loop, is this statement here. Next, we have a condition. We're testing to see if I is less than 3. And if this condition is true, we'll execute this loop. You can see the body of the loop here between opening and closing parentheses. And this final part here is a statement that'll execute after the loop completes. So if you remember, the plus plus operator is called the increment operator, and it adds 1 to I. So when this code executes, I starts out at 0, and 0 is less than 3, so we'll log out I, which is 0. And the loop has ended, so this statement executes, I++. Now I is 1, and 1 is less than 3, so we log out 1. Then we'll increment I again, so that I is 2, and 2 is less than 3, so we'll log out I, which is 2. We'll increment I, because we're at the end of the loop again, and now I is equal to 3. And 3 is not less than 3, so our loop is done. Our code will continue executing below the body, but this for loop is complete once this condition returns false. So the result of this loop are the values 0, 1, and 2 being logged out. The loop executes 3 times. So let's look at this loop here. We use the for keyword, and we'll declare I to be equal to 0. And as long as I is less than 5, we'll log out I. And after the code body completes, I will be incremented. So let's see what this shows in the console. I'll save it. And we get the values 0, 1, 2, 3, and 4. So that worked as expected. We'll be using loops later on in the course when we start to modify the web page, the DOM. But for now, let's just start with these simple examples. One common bug is the condition. Sometimes you'll see something like less than 5 or less than or equal to 5. And of course, these produce different results. I'll save this. And you can see that now the numbers go from 0. Let me scroll up here. The values go from 0 to 5. So you always want to be careful what you're doing, whether you want less than 5 or less than or equal to 5. Now there's one thing that can go horribly wrong in a loop, and that would be if the loop never completes. What if instead of I++, we said I minus minus by accident? That'll decrement I, and the condition will always be true. I will always be less than 5. Let's save this and see what happens. So you can see the values showing up in the browser. They're getting negative very quickly. We're up to negative 20,000 or more. And it's jumping quickly. You'll also notice that the web page stopped showing. So we're in what's called an infinite loop. This is going to continue and we're stuck. Let's try to stop it by hitting the X button in the browser. So that seemed to stop the web page from loading, but our values are still showing up in the console. And this is a big problem. Right now the browser is hung up. There's no way to stop it. I can try to refresh, but nothing happens. The JavaScript is still executing in the background, and our values are still going up and up in the console. And unfortunately, the only way to kill this is by exiting out of the browser. So I'll do that and I'll restart. So I restarted the browser, and I'm trying to go back to the web server. And even though I shut down the browser and restarted it, there's still a problem on the web server. Let's exit the page because waiting is doing no good. And we get an error. I'll try to refresh. And again, you can see that the web server is still hung up. So I'll go to Visual Studio Code and I'll hit Control backtick. That'll bring up the server and I'll shut it down with a Control C. Terminate batch job. I'll hit Y for yes. I'll stop the browser. Now, before I start the server, I'm going to fix the code. We're going to say I++ instead of I-. You can see how much trouble this endless loop caused. We had to shut down the browser. That didn't work. We had to shut down the server. But let's fix the code and then restart the server. So the code's fixed and I'll save it. And I'll execute npm start. And I'll start up the browser again and everything's good. So you can see the dangers of working with loops. You have to make sure that the loop comes to an end. Otherwise, you'll get stuck like that. You may need to reboot your web server or you may need to restart your browser. So this is one kind of loop. It's called a for loop, but there's another popular kind of loop called a while loop. We'll see that next. We just saw how to loop with a for loop, but there's another kind of loop called a while loop. Let's take a look at this one. We'll declare a new variable count and we'll set it to 1. And then we have our while loop. So we use the while keyword and we specify a condition, just like we do with the for loop or an if statement. While count is less than 5, we'll execute this code block. So we'll log out count and then we'll increment count. And incrementing count is vital. We don't want to get into another situation where we have an endless loop. We saw the trouble that can cause. So count starts off at 1 and we log out 1, 2, 3, and 4. But by the time count gets incremented to 5, 5 is not less than 5. So the loop completes and code execution continues after the body of the while loop. Let's see this in Visual Studio Code. Now here I'm using the variable I. And you saw this earlier, but I is a traditional variable name to use in loops. It stands for index, or it could also stand for iterator. But you'll often see single variable names such as I, J, or X, Y, and Z used in loops. So here we're setting I to 4, and while I is greater than 0, we'll log out I, and we're counting backwards in this example. So we'll decrement I. I will go from 4 down to 0. I'll save this and we'll see what we get in the console. Looking in the console, we have the values 4, 3, 2, 1. And again, it's very important to look at how the loop begins and ends. We're setting I to 4, so that's the starting point. But by the time I becomes 1 and we decrement it, I will be 0. And 0 is not greater than 0. So the loop ends there. 0 never gets a chance to be logged out. So this is quite a bit simpler than a for loop. You just have the condition after the while keyword. But you absolutely need to make sure that the loop will come to completion. Otherwise, things could get hung up again. And there's one other loop I'd like to show you in the next clip. It's a do while loop. The final loop we'll look at is a do while loop. You use a do while loop when you're guaranteed that the body of the code will run at least once. Let's take a look at this. We're creating a new variable count and setting it to 1. And then we're using the keyword do. That's the beginning of our do while loop. So we have do followed directly by the code body. Those are the commands between the opening and closing parentheses. And then we have the keyword while and our condition. So this code block is guaranteed to execute at least one time. So it'll print out 1, increment count, and then while count is less than 5, it'll continue to execute the code block. So this code block will execute 4 times, showing the values 1, 2, 3, and 4. So this is similar to the while loop. The while loop tests the condition at the beginning, but here with a do while, the while is testing the condition after the code block executes. So here's a live sample. We're setting I equal to 4, I is a new variable, and our code block is guaranteed to execute once. And while I is greater than 0, the code block will continue to execute. So again, you need to be very certain that at some point in the future, this loop will end. And it will because we're decrementing I. I'll save this and we'll see what we get. We get the values 4, 3, 2, 1 showing up. Now what if we started off by setting I to -4? So I will be -4, we'll log out -4 here, and then we'll decrement I to -5. Let's see what shows up in the console. We get -4. So again, the code block is guaranteed to execute once. That's how we get our -4. And this while condition is never met. I is always negative. So the code block executes once and then we're done. Code will execute from line 7 on after this. So those are the key loops that we have in JavaScript. We've seen how to use for loops, while loops, and do while loops. Let's wrap up this module with a summary. We started off this module by looking at if-else statements. Based upon a condition which evaluates to true or false, we can execute certain code. And in the else clause, we can execute code if the condition is false. We looked at truthy and falsy expressions, and we saw how certain variable values evaluate to true and other ones that evaluate to false. So 0 as a string is true, and every number is true except for the number 0 without the quotes. And we also saw how values such as null and undefined are false. Next, we took a look at comparing the triple equal sign to the double equal sign. And we learned to always use the triple equal sign for identically equal to, and the not equal sign as identically not equal to as a best practice. These make sure that you're comparing numbers or objects or anything of the same type. By using the double equal sign or not single equal sign, JavaScript might try to convert types, which isn't always intuitive. Next, we looked at the ternary operator. That's where we have a condition and then the question mark symbol. And based upon the condition, if it's true, there's a true statement, colon, and if it's false, there's a false statement. And this is a concise way of writing an if-else statement. You can do it all simply on one line. Next, we looked at block scope. We saw how variables that are declared with let or const are block scoped. The variables only exist in that block, and once the block completes, they disappear. And this is one reason why we declare our variables with let or const instead of var. Finally, we took a look at several different types of loops in JavaScript: the for loop, the while loop, and the do while loop. And we need to be very certain that our loops will complete. The browser can get hung up if they don't. And in certain circumstances where our browser is strictly tied to our development web server, even the web server could get hung up. So whenever you write a loop, just be sure that the loop finishes execution at some point. And all of these things we looked at in this module refer to program flow, whether we include or exclude blocks of code, or whether we loop over code. And in the next module, we'll take a look at functions. A function is a block of code that we can give a name to and call it over and over. And most of the code that you write in JavaScript will exist within a function.